All right, guys, we are going to be going over the version 1 FRQ from the Try 1 final exam. So, very first question talks about a particle moving along the x-axis and it gives us a velocity equation. So, when we are told that we are allowed a calculator, when I graded these, I saw a lot of people using quotient rule. That is not going to be the best use of your time. It asks you to find acceleration at time t equals 7 and include units. And we know that acceleration is the derivative of velocity. So instead of trying to use quotient rule and then plugging in t equals 7, I would highly encourage you to pull up that calculator and use that math 8 function. I'm actually going to put this in y equals because I realize that there's going to be some other times that I'm going to need to look at the graph. So I'm going to go to my y equals, click on that alpha y equals, to get that stacked fraction. And then I'm just going to plug this in. All right, after we have this plugged into that y equals or that y1, I'm going to kind of get out of here for a second, so second mode. And then I'm going to go to that math 8. Remember, we're taking the derivative with respect to x. And in this little parentheses, instead of typing that whole thing again, I already typed it into y1. So I'm going to click on this vars, y vars, and I'm actually going to have that function y1. We are looking for the acceleration, so that's the derivative of function y1 at the value t equals 7. And there we go. So to summarize this, we know that that's what? 13.396, 3 decimal places. Make sure you're being careful with rounding. So I'm going to do a few things here to get max credit. I'm going to say right here that v prime of t equals a of t. And then we're going to say a of 7 equals 13.396. And remember, we need units. So it says velocity is meters per second, which means acceleration is going to be meters per second squared. Looking over at the rubric for part A, you would have gotten, I think on this rubric, it was 1 point for the answer and 1 point for the units. So you got 2 points total, 1 for answer, and then 1 for units. All right, this next one is going to require a little bit of calculator work. We want the speed for which it is 1. So I'm going to come in here and make a little bit of notation just so we're like kind of aware of what's going on. I know that the absolute value of velocity equals speed, which means that velocity can equal plus or minus 1 in this scenario. Because remember, speed is not indicative of direction, right? So velocity is speed with direction, which is why that negative sign shows up. So I'm going to come back here to my graph, and let's do some little zooming right here. So let's do a zoom fit just to make sure that I'm going to get my entire function happening. There we go. And we're looking for an interval of 0 to 2. So you can go over here, and I might go to my window and make my x max like 5. I actually might change this guy. Let's do like a -5 to 20. So I'm looking for everywhere where it's +1 or -1, which on this interval from 0 to 2, it looks like it's going to be +1 like one time and -1 another time. So let's get that done. I'm going to type in a 1, and then I'm going to type in a -1, and look at that graph, and indeed it is intersecting 2 times, so once at that +1, once at that -1 over that interval 0 to 2. So I'm going to grab both of those values by doing that second trace 5, enter, enter, enter. That is not the intersection I want. Let's get this guy really close to this intersection. I know I'm going to want this guy right here. So there is my first intersection, 0.772. And then my second intersection is going to be 1.401. So I'm going to come over here and I'm going to say t equals 0.772 and 1.4, let me get that correct, 0.1 with rounding. This was also 2 points. It was 1 for each answer. If one or more time t exists, where the particle is at rest over the interval 0 to 10, state those times. So once again, I'm going back over here. Let's get this kind of cleared out and reset my window. We are looking now at an interval 0 to 10 seconds. So I'm probably going to go over here to my window, bump that up to 10, maybe 11. And it's at rest wherever velocity equals 0. So we know what this means is v of t equals 0. So essentially that's wherever that function crosses the x-axis. It looks like this is happening 2 times. So I'm going to go to that menu, I'm going to go that second trace, I'm going to come down over here to that 0. When it asks for this like whole left-bound, right-bound situation, remember it wants like 1 point right to the left and then 1 point to the right because it's essentially taking the average. So there's that left, then I'm going to go to the right. So we're kind of like hugging that solution right there, or that x-axis cross. And it looks like one of my solutions is going to be 3.596. And that other solution, same thing going on here. We need to come over and hug that 0. So here's that left bound. Here's that right bound. And then that other solution is positive 1. And because it says justify, we need to come in here and say because velocity equals 0 at those points. So you would have gotten 2 points again on this one, 1 point for the values, and then 1 point for the justification. Looking at part D, it asks at time at t equals 1.5, is the particle speeding up or slowing down, and then justify your answer. So we really want to look at like 2 different things here. We're looking at the sign of what the actual value is. So like what is the sign of v of 1.5, and then what is the sign of the derivative or acceleration. So either v prime of 1.5 or a of 1.5, right? And we're asking ourselves like what is happening here? Positive or negative velocity or acceleration. So if I come over here back to my calculator, let's calculate that value. When x equals 1.5, my y value is negative. So I'm going to come here and say, like, I know that the sign of that is negative. And then if I come over here and I look at, like, okay, well, what's happening to my slope? You can tell that your slope is negative, but to ensure, you can go to that second trace. Again, that menu is just great. dy over dx. And I see that, again, my derivative is negative at that point. So I'm going to come over here and say that my acceleration is negative. So I'm going to say the particle is speeding up because both velocity and acceleration are negative. Because it doesn't ask for the values, you do not have to like actually find that actual number, but you do need to say, like, don't just say that they're the same sign, because like anyone can say that, right? Like we need to say like, yes, I know, because they are both negative. So again, 2 points here. 1 point was for naming speeding up. So 1 point for like literally saying speeding up. And then the other point was saying that both velocity and acceleration are negative, or giving the exact values and like including the fact that they were both negative. So give yourself a score on this very first FRQ. All right, second one going on here. The very first part asks, what is f of -3? So because that we have a piecewise function here, I need to be looking for like which one of these pieces includes the domain of -3. Less than or equal to -3, so this is just that flat horizontal line. So I'm just going to name here f of -3 equals -5. That was 1 point. So if you were grading your own work, you would have just said, okay, 1 point, we're good to go. Is f of x continuous at x equals 0 and justify your answer? It's super important to note that continuity means that like several things are happening, right? We need to like note that the limit as x approaches 0 from the left equals the limit as x approaches 0 from the right. And that also equals f of 0. So those all have to be equivalent because what we're saying is that they're both approaching the same value, and then there's also not a hole at that point. So you can't just say that they're approaching the same value, but it also has to be like filled in. So let's get this done. It looks like that x equals 0 continuity is going to be utilizing these two pieces of my piecewise function. So I'm going to come over here and say the limit as x approaches 0 from the left of f of x equals, we're going to have negative 3/2 times 0 minus 1/2. The limit as x approaches 0 from the right, so that's everything greater, right, is going to be 0 plus 3 over 3 times 0 minus 6. This guy right here equals negative 1/2. This guy right here also equals negative 1/2. And then I'm going to come here and say, what is f of 0? That's going to be included in this piece. So we see that it's included, which means it exists. So f of 0 equals negative 3 over 2 times 0 minus 1/2 equals negative 1/2. So in here, we're just going to like come over here and make a conclusion. And I'm going to say the limit as x approaches 0 of f of x equals negative 1/2. This also equals f of 0. So we're going to say, therefore, f of x is continuous at x equals 0. So this guy right here had 3 points happening, and how those 3 points were broken up is we needed to like have some sort of notation to show left and right hand sides. So like we needed something about this left and right hand side. We needed to also show that f of 0 was negative 1/2, and then some sort of conclusion about continuity. So some sort of like limit notation, right? We need to show that the left and right approach the same value. We need to show that f of 0, and then we also had to have some sort of conclusion. So like, yes, it's continuous because they all are the same value. So this guy was at a 3. Sorry, that guy was at a 1. Is f of x differentiable at x equals 3? So we are now looking at a different two pieces because we're asking about differentiability and we want at x equals 3, we're going to be utilizing these two pieces. So remember, for differentiability, we first have to prove continuity. After continuity, then we'll move on to that like differentiability statement. So very first thing I'm doing here is I'm going to say, is it continuous? So limit as x approaches 3 from the left needs to equal limit as x approaches 3 from the right needs to equal f of 3. So once I get that done, I'm going to get that done pretty quick here. So here we have my continuity statement. So therefore, continuous. And I kind of like paused into that work. So like you need to prove continuity first. Unfortunately, where continuity is worth like 3 points in that previous, it's only worth like 1 point here. So proving continuity first, then we move on to differentiability. Because remember, if it is not continuous, it is not differentiable. Okay, so I just kind of threw a lot of work up here, and the bottom line here is that we need some sort of proof that you know which two pieces you're using and you know which two pieces to differentiate. So some sort of formal definition of like, we need to know that we're using these two pieces of f of x, and then we need to know that when we differentiate, these become these two pieces right here. We also need to know that for it to be differentiable, that the limit as x approaches 3 from the left of the derivative needs to equal the limit as x approaches 3 from the right of the derivative needs to equal that derivative value. So again, we're just playing with a bunch of substitution here. And then we get that that negative 1.667 does not equal negative 2. And then we can say, therefore, not differentiable. So this guy was a little bit tricky. You did need, so you got that 1 point for that continuity. You also got 1 point for knowing that you had some sort of notation that was indicating that you were derivating. So some sort of indication that showed that you were looking at the approaching of both sides. Then you got a point for having correct values, and then a point for saying that it was not differentiable. So lots of random stuff here out of 4 points total. 1 point was for continuity. 1 point was for notation. 1 point was for values. And then 1 point was for the justification, or the conclusion, sorry. That justification would have been that work or that notation. All right, very last one. We are looking at some related rates, implicit differentiation. Let's go for it. A calculator is allowed for this question. Show all work. Great. A 26-foot ladder is leaning against a building so that end B is on level with the ground and A is on the wall. All right. So I'm going to go ahead, and I always do like X, Y, Z. We know this is a 26-foot ladder, so I'm just going to write that down already. Someone starts pulling the ladder away from the building. So if I'm pulling the ladder away, that means this X is going to be increasing, or we're moving to the right. And end A starts sliding down the building. So we're moving down. Here's my notation. At a constant rate of 4 feet per second. Find the rate of change at which the base of the ladder is moving away from the building when A is 10 feet up the wall. So if A is 10 feet up the wall, that means Y is 10. Because it is moving down, sliding down the building, I'm going to come over here and see dy over dx equals negative 4. We don't know. We want to know what dx over dt. Whoops, I said dx. And I know that that ladder is never going to change, right? My ladder is not compressing, getting smaller or larger. So I'm going to say that this is going to be 0 feet per second. We're going to come over here, since we have a triangle, we're almost always using Pythagorean Theorem. So I'm going to come over here and say that x squared plus y squared equals z squared. And then let's actually solve for x really quick here. So we know that we have a 10 squared plus y squared equals 26 squared. You may use your calculator here. Or you can recognize that like Pythagorean triple, right? And I know that this needs to be 24. Or right, like that 5, 12, 13. This is an iteration of that. So then I'm going to come over here and implicitly differentiate because we want the rate at which x is increasing by. So I'm going to come over here and say that this is 2x dx over dt plus 2y dy over dt equals 2z dz over dt. We can cancel out all those 2's, or you can keep them. It does not matter. I like to kind of get rid of things if they're going to impact my values. You know that this right here is going to be multiplied by 0, so I'm not even going to worry about that. X is 24. We don't know dx over dt. Y is 10. We do know dy over dt. It's negative 4. So we have 24 dx over dt. Because this is 0, if I move this over, it's going to be positive 40. So I'm going to divide by 24. When I do that, I get 1.66666 repeating, right? So we're going to round to 3 decimal places, 1.667. So I'm going to say dx over dt equals 1.667. And because this is increasing, we have positive feet per second. So there are 4 points total here. You would have gotten 1 point for correctly noting that you were using Pythagorean Theorem. You would have gotten 1 point for correctly solving for, oh my goodness, I did y this whole time. whoops, for correctly solving for x. So solving for x and getting that that equals 24, right? You would have gotten 1 point for using correct implicit differentiation, and then 1 point for that answer. So 4 points total. Pythagorean theorem, missing value, implicit differentiation, and then answer with units included.